वो नहीं करेगी, अभी उसका एग्जाम चल रहे हैं।
ओह, अच्छा।
हम्म,
कोई नहीं सर, हम लोग कंटिन्यू कर देता अब।
है ना। हम्म,
यस।
तो फेजांस रूल है, देखो मॉलिक्यूलर ऑर्बिटल थ्योरी पढ़, फेजांस रूल पढ़ना चाहिए शायद ना हम लोग। तो फेजान रूल जो होता है वो एक्चुअली वो बताता है कोवेलेंट कैरेक्टर को। कि किसी भी चीज में कोवेलेंट कैरेक्टर क्या है, कितना है। कोवेलेंट कैरेक्टर जो होता है वो हम डिसाइड कैसे करते हैं किसी भी मॉलिक्यूल का, वो हम डिसाइड करते हैं ऑन द बेसिस ऑफ पोलराइजेबिलिटी। ठीक है। पोलराइजेबिलिटी क्या होता है, पोलराइजेबिलिटी होता है, पोलराइज ये चीजें जो होती है कोवेलेंट कैरेक्टर है, पोलराइजेबिलिटी ये डिपेंड करती है कुछ फैक्टर्स के ऊपर। जैसे लार्जर द चार्ज ऑन द आयॉन्स, दूसरा स्मॉलर द साइज ऑफ कैटायन, तीसरा लार्जर द, हाँ द थर्ड वन इज लार्जर द साइज ऑफ एन आयन। See, let's understand what is polarizability first. Polarizability is whenever you have two molecules, like one molecule in which two atoms are there, one is A and other is B, and there are two charges, positive charge and negative charge. Hmm. Wha- what is polarizability means, what is polarization? When the negative charge, this negative charge, suppose this negative charge is reduced to neutral, and then it moves from neutralization, it moves from negative charge to neutralization to positive charge, then that means this atom B minus charge is getting polarized. Polarized means the tendency of any other ion to change its negative charge to positive charge. Okay.
Okay, sir. So
Similarly,
that positive charge will be getting more larger and larger.
no, size will be same.
Okay.
It only,
Okay.
see, under the influence of the size of A and B, you cannot change the size of the A and B. Na? They are the atoms. You cannot just change the
Yes.
sizes. It's permanent, the
Yes.
size is permanent. But under the influence of A, but we do not know, see, this atom A can be changed. This atom A can be anything. It can be some Ca2 plus or Mg2 plus or some Na plus,
Any ions.
any ion it can be. So
Okay.
it depends on whatever ion is present here. It depends that this ion, how much influence this ion can do on the B. If the influence is more, if the influence of A is more, then it will, what it will do, it will try to polarize it. To polarize it means it will try to reduce its negative charge to zero. How it will reduce? See, if the charge on this A is higher, suppose it is +2, or the size of A is smaller, in that case what will happen? In that case it will influence the negative charge more, it will influence the electron of B more, and the negative charge is present on B because of the electron, because electrons are
Okay.
supposed to be negative charge, no?
Yes,
So
sir.
then what will happen, because of the influence of this positive charge, these electrons will migrate towards A. And then
Okay.
when electrons are migrating towards A, that means the B is losing its negative charge, means it is getting polarized.
Okay.
Polarization means negative charge converting to positive, and
Positive.
positive charge converting to negative. That is called polarization.
It's just like the positive charges are gaining negative charges and converting into positive,
Hmm.
and negative charges are being converted into negative,
Positive.
and that like I'm saying that positive charges are being converted to into negative and going to like B.
Hmm. Becoming like
Oh,
B,
yeah,
like
okay,
that.
I understand.
So on this is known as the polarizability. Means
Oh,
polarizability means you're trying to if suppose some situation arises, the charge on the ion is converting it into another one. Means the positive charge is getting converted to negative one, negative charge is getting converted to positive one. This is known as a
okay.
polarizability, and how stronger it is, that decides the covalent character of a molecule.
Okay, can we take the two example like first is Na and second is Cl? Can we
Hmm.
do that with that two elements? It's like Na will lose, so it will be positive, and Cl will be gaining to
Hmm.
complete its orbit.
Hmm.
So it will be polarized.
Polarized, huh? But it's
Okay,
not. It's see this Kanishka. This is NaCl is not supposed to be this covalent. It is supposed to be ionic, because see why? Because this NaCl is actually formed because of the electrostatic attraction between Na plus and Cl minus. Earlier,
okay,
earlier they were this covalent character actually we find in those molecules in which electronegativity difference is less.
okay.
Only means in the case of only p block atoms or p block molecules. Those p blocks I have told you na earlier. This is your
Yes,
p block. Let me show you. Hmm. These na boron, carbon, nitrogen, oxygen, sulfur,
yes,
these are known as p block. But when you are making bond between s block elements and the p block elements, that bond is
yes.
supposed to be ionic.
Okay,
Why? Because this is very highly electropositive. They made a bond because of the electrostatic attraction between the positive and negative charges.
okay,
It was already electropositive, it was already electronegative, and there was very high electronegativity difference between these two. That's why they have formed a bond, and that is called ionic
bond.
bond. But
Okay, so it will be not like polarized
hmm,
form. Oh,
yes, there won't be a polarization. There we won't talk
okay,
about polarization here. We talk about
okay,
polarization only when we are trying to decide the covalent character only in those molecules in which atoms are only of the p blocks.
okay. Just like you have, if we try to convert X block,
Hmm.
taking like only of X block, that will be polarized. Same with P block.
Hmm.
Okay, I get it.
Now I'll give you one example. See, suppose if we take an example like SnCl2, suppose we have taken one is SnCl2 and other is AlCl3. Now, if you see, this is one Sn, one Cl, one Cl, and this is aluminium. This is one Cl, this is one Cl, so this is one Cl. Okay. Now, if we see the covalent character, these chlorines are minus minus. This is plus 2, supposed to be in plus 2. This is minus minus minus. These are plus 3. Okay. Now, if you see here, this aluminium is plus 3, correct? This is plus 2. So the
Yes.
intensity, so the intensity with which this aluminium will try to polarize the Cl minus will be higher. So these electrons will be attracted towards them. So it will lose its charge. So negative charge. So it will become zero, or positive try to become positive, because the electrons are going towards Al3 plus with more intensity rather than Sn2 plus. Understood?
Yes, sir.
So in these two, if we compare Sn2 plus SnCl2 and AlCl3, which will be more covalent? AlCl3, because it will be polarized more.
Yes, sir.
Understood?
Because it is having more Cl.
It no,
That's why.
it's having more positive charge on itself.
Oh, yes, sir. More positive charger. Yeah, I understand.
More positive charge means it will try to attract more electrons from the negative uh,
Diff
ion,
charge. Yes.
negative charge Cl minus. And once the electrons are getting attracted towards Al3 plus more, then it will lose its negative charge very quickly because it has lost electrons.
Okay.
Okay,
Okay. Yes, sir.
this is known as the Fezan rule. And this Fezan
Okay.
rule, actually, what they say, this Fezan rule is actually, it says that covalent character is directly proportional to the polarizability. Polarizability we have understood, but they have said that polarizability depends on three factors. Larger the charge on ions, means this example I have taken, if on Al3 plus charge is higher plus 3 rather than Sn2 plus, so it will influence more. So Al3 plus is higher than Sn2 plus now. So it will influence more. So larger the charge on ions means greater polarizability. This we have seen is this in this example, right?
Yes, sir.
And
Okay.
other thing is if the charge is same but size of cation is less, means
Okay.
suppose you take um, boron and aluminium. You take the example of BCl3 and AlCl3. Okay. Now, if you
Uh,
see, if here the second example I am telling, if you see both these, they are similar. Means B also has plus 3 charge, and these Cl they are three chlorines minus like this,
yes.
and Al also has plus 3 charge, plus 3 Cl minus and Cl minus. Now how to decide which will be more covalent? They said because boron is smaller in size. Why? Because in the group it goes boron, aluminium, gallium, indium, thallium.
Okay.
In the periodic table it is. So
Yeah.
from if we move from higher to lower in the periodic table, the size increases. This is of the smaller size, smallest size, small to high, and this is
Also
of
high.
small to high. The size increases,
High. Okay.
and similarly in the period it decreases. In the period it will decrease. But we are talking about group, so let's stick to the group only. Boron
So
is
like, smaller.
hmm,
It's like in group we are talking about, you said that, so we will working on the smaller to higher
hmm,
elements.
hmm. So now
Okay.
boron to aluminium, if you move, boron also has plus 3 charge, aluminium also has plus 3
That's
charge,
plus.
but what is the problem here? Plus 3 charge is present on the smaller size. Here plus 3 charge is present on the higher size, more size. So the positive charge will be dispersed more. It will be
Okay.
dispersed less. So the influence of the plus 3 charge present on the smaller size will be greater than the same charge which is present on the higher size,
Okay.
because the charge will be dispersed more. That's why the smaller the size of cation, greater is the polarizability.
Oh,
Okay.
yes, sir.
The third case arises when you have the same cation. Means
Uh, like
here,
same charge, like
no,
just like
uh,
3 plus, like boron has 3 plus and Al has 3 plus.
no. Here we are
Uh,
taking different examples. See, here the example is, suppose I have taken one as AlCl3 and the other I have taken as AlBr3.
okay.
Now how to decide which is more covalent here? Here both of them has
Suppose.
same cation. Means this is also Al3 plus and Cl minus, Cl minus, Cl minus. Here
Yes.
also you have Al3 plus, Pr minus, Cr minus and Br minus.
Yes.
Here they both are same. This is same and this is same. So on the, if you cannot decide the polarizability now on the basis of this
Can
uh,
we look on the size, like
hmm,
which one is larger and smaller?
aluminium is same na, both aluminium is same,
Yes,
so
both
they
are
have the
same.
same
Though
size.
size, yeah.
Size of chlorine you
So
will look, chlorine and
yeah,
bromine,
chlorine and boron.
bromine.
Bromine, sorry.
Bromine comes after this, chlorine, fluorine, chlorine, bromine, iodine. group going like this. So bromine has the higher size rather than chlorine.
Oh,
So they said larger the size of anion, greater is the polarizability. Because when the anion is higher, when an anion is higher in size, it's easier to attract electron from it.
okay. It's
Because
just like if we're yeah, if we're like given an example of Al and Cl3 and same air, so if the left side of the elements are same, it's like you have to look on the size of those element which one is the larger size,
hmm,
and we will find out that which one is larger element.
yes, then you will find
Okay.
which has the greater polarizability, that will be more
Polarizability.
covalent.
Yes. Yes, sir. Okay.
So here in these cases, AlBr3 will be more covalent than
Got-
AlCl3. Understood?
Okay.
This is how
Okay,
we
sir.
find out. I'll give you an example. Question I'll give you.
Can we do one question?
The question will. Okay, try to solve this one.
Okay. I will do like the same as above you did, like taking all the opening all the elements and then I will solve like that.
Like that.
That which one has having the larger size.
Correct.
Okay. Okay, then I will be able to do it. Sir, is the answer is the C one?
AlCl3, correct.
Okay. Sir, can you give one more question?
One more question. Let me see.
Okay.
To this question, they actually not they will not ask many difficult questions on this. It's easy one only. Mm, Try solving. क्या हुआ, बहुत टाइम लग गया?
तो ये सॉल्व हो गया। सर क्या इसका आंसर सी होगा क्या?
नहीं,
क्या?
बी होना चाहिए ना।
गलत? बी?
अरे
गलत
भाई,
होगा फिर।
देखो ना, देखो कैल्शियम जो है, ये कैल्शियम तो तुम्हारा फर्स्ट एस ब्लॉक में आता है ना।
हाँ।
तो ये तो हाइड्रोजन के साथ अब ये बनाएगा, तो ये तो वैसा बनेगा CH2, ये हाइड्राइड है, ये है ये Ca2+ है, ये 2H- है। हाइड्रोजन तो
ओ।
कंट्रोवर्शियल होता है ना, पर ये तो एस
हाँ।
ब्लॉक, ये तो एस ब्लॉक का एलिमेंट है, तो ये तो आयनिक बॉन्ड बनाएगा, यानी इलेक्ट्रोवैलेंट बॉन्ड। और
ओ।
सी और Cl में कार्बन भी पी ब्लॉक है, और क्लोरीन भी पी ब्लॉक का ही है, तो ये कोवेलेंट बॉन्ड बनाएगा ना।
ओहो, मैंने उल्टा बोल दिया।
हम्म।
मतलब बी बोलना था मुझे, मैंने बोल दिया सी।
हम्म। कोवेलेंट
ठीक
है
है
ये।
सर। ओके। यस सर।
तो हो जाए, इस ऐसे ही क्वेश्चन आते हैं इस पर, कनिष्का, इजी इजी, ज्यादा मुश्किल नहीं होते।
यस
अच्छा,
सर।
अब चलते हैं इसके बाद वाले पे।
ठीक है।
मॉलिक्यूलर ऑर्बिटल थ्योरी। मैंने हाइब्रिडाइजेशन वगैरह कंप्लीट कर लिया ना? हाँ हाँ, ठीक है,
हाँ हमने कर लिया था।
कर लिया ना। और वो क्या कहते हैं उसको, डाइपोल मोमेंट, वो भी हो गया ना।
हाँ सर वो भी हो गया था।
हम्म। मॉलिक्यूलर ऑर्बिटल थ्योरी बची है। तो मॉलिक्यूलर ऑर्बिटल थ्योरी क्या होता है ना, जैसे प्रॉब्लम क्या थी कि जो वैलेंस बॉन्ड थ्योरी थी ना, वैलेंस बॉन्ड थ्योरी में उन लोगों ने हर चीज क्लियरली नहीं बताई थी, मतलब वो मॉलिक्यूल को ठीक से नहीं एक्सप्लेन कर पाए थे, मॉलिक्यूल का स्ट्रक्चर उन्होंने सब कुछ बता दिया था, लेकिन कुछ चीजें जो मिसिंग थी ना, वो उन्होंने मॉलिक्यूलर ऑर्बिटल थ्योरी के थ्रू बताई थी, जैसे मैग्नेटिक कैरेक्टर, मैग्नेटिक कैरेक्टर, और कोई भी मॉलिक्यूल जो होगा वो डायमैग्नेटिक होगा कि नहीं, या फिर पैरामैग्नेटिक होगा, ये सब चीजें, उसमें कितने लोन पेयर रहेंगे, आगे अकेला लोन इलेक्ट्रॉन रहेगा कि नहीं, ये सब जो चीजें थी ना, ये इन्होंने मॉलिक्यूलर ऑर्बिटल थ्योरी के थ्रू बताई थी, मतलब प्रॉपर बॉन्डिंग एंड नंबर ऑफ इलेक्ट्रॉन्स विच आर इन्वॉल्व इन द बॉन्डिंग, और ये सब चीज इन्हें मॉलिक्यूल, इन्हें एटम तो इन्होंने पहले वाले वैलेंस बॉन्ड थ्योरी तक अच्छे से एक्सप्लेन कर दिया था, लेकिन मॉलिक्यूलर ऑर्बिटल थ्योरी में उन्होंने मॉलिक्यूल के अंदर जो प्रॉपर बॉन्डिंग होती है वो एक्सप्लेन की थी। अब इस थ्योरी में इन्होंने क्या बताया था, ये बताया था कि एक्चुअली में जब भी बॉन्डिंग होती है ना, मॉलिक्यूलर ऑर्बिटल थ्योरी में, तो जब बॉन्डिंग होती है, तो ऑर्बिटल्स जो होते हैं ना, जैसे सपोज मेरे पास 4 ऑर्बिटल है, तुम डिफरेंट डिफरेंट ऑर्बिटल्स तुम जानते हो, जैसे ये है सिग्मा, और ये है, सॉरी, ये है एस ऑर्बिटल, ये है पी ऑर्बिटल्स, ठीक, पी भी होते हैं डिफरेंट डिफरेंट ऑर्बिटल्स। तो
यस सर।
उन्होंने ये बताया कि कोई भी ऑर्बिटल, चाहे वो एस हो या पी हो या डी हो, ये मॉलिक्यूल बना रहे हो तुम, जैसे ए और बी, दो एटम्स को मिलकर एक मॉलिक्यूल बनता है। अब ए का एक ऑर्बिटल होगा, बी का एक ऑर्बिटल होगा, देयर विल बी वन ऑर्बिटल ऑफ ए, वन ऑर्बिटल ऑफ बी। नाउ when each orbital of one atom and each orbital of second atom, they are overlapping, one orbital of A, one orbital of B, they have overlapped, then they overlap in two ways, one constructively and one destructively. I can explain you using the wave concept, what is constructive and destructive. See, they have explained actually the orbitals are nothing but waves. Okay, Schrodinger wave equation. Remember this na, in NCERT it is. That wave equation is
यस
not
सर।
important to us, but because further studies are not given to your syllabus, given in your syllabus, But what they have told, the orbits, they are represented by waves. And when two waves superpose on each other, they do it two ways. One wave this, other wave is this. Means this is known as crest, this is known as trough. This is again crest of second wave, this is trough of second wave. Now when they superpose like this, one wave kept upon another, they superpose like this, they create a wave which is like this.
It goes like positive to negative, negative to positive.
This is the representation of a wave. Later you will understand in physics, I'll teach you the wave chapter. There you will understand a wave can be represented in this form, either in the sine. This is actually the sine curve. The wave is
Sine.
represented like this.
Yeah, like sine theta.
Sine theta, yes. Now, when this had the amplitude A1, this had the amplitude A2. Now, when they superposed, this new wave became, the amplitude became A1 plus A2. Means the amplitude of this and this they have added up.
Okay.
This kind of superposition is known as constructive.
Constructive.
Now,
And in the negative side, it will be A1 minus A2.
correct. Yes. Why? Because the second type is like this. One wave
It's
is
like changing the direction.
one wave is
It's going upwards and downwards, upwards
correct,
and down.
correct, like this.
Okay.
This is A1.
This will be also known as like constructive only, or
No, this is destructive.
destructive. Okay.
This is destructive.
That's constructive, which is going upwards. Downward going means destructive. Okay.
They have superposed, means this has superposed with this. Now these waves are represented by these waves. These waves are actually orbitals in our case. Each orbital is represented as a wave. Okay. Now when they superpose, this is one orbital, this is other orbital. When they have superposed constructively, they make this type of orbital, this lower one. Suppose this is sigma, this is one orbital, this is also sigma.
Okay.
This is constructive one. And constructive, because constructive one is supposed to have lower energy, because constructive one is supposed to be more stable. This is actually energy line.
Okay. If we draw just like a straight line, so it will start from the upwards and then down, up and down. Okay.
This is of
and
lower
the destructive one will be
higher energy. This will be like sigma asterisk. This is destructive one. Why? This is higher energy because it is supposed to be unstable.
Okay. So basically, the lower energy one is the constructive one, and the higher one is the destructive one.
Destructive one. Now the concept is when you superpose two orbitals, two different orbitals. If these orbitals are supposed to make sigma bonds end to ends, they will either overlap constructively, making sigma, or they will overlap destructively, making sigma asterisk. Or in the case, suppose two orbitals are overlapping through sidewise.
So, but why does the higher one does not have constructive one, and the low energy one does not have the destructive one?
No. These orbitals, when they overlapped two ways. One way was constructive way. Constructive one was sigma. Now, the other way they could overlap is through destructive way. That is sigma asterisk. Both we have represented, no? This and this, they both are the outcomes of these two over superposition of A and B.
Oh, okay. Now I understand.
Now understood, no? Now in the same way, if these two orbitals of different two molecules, A and B, they have overlapped, suppose, using sideways, means pi and pi. So similarly, they will make pi means
So the black area will be the constructive one,
this will be constructive.
a- and the pink area will be the destructive one.
Yes, destructive one.
Okay. Okay.
See, these things that I have told you, this destructive and constructive one, nobody will tell you in your class. Actually, what they will tell, they will tell this is called as bonding. This is known as
Oh,
bonding orbital, and this is known as anti-bonding orbital. The destructive one is known as anti-bonding,
anti-bonding. Okay.
anti-bonding orbital. In every
Okay.
case, if they are overlapping end to
Con
end, there will be bonding orbital for sigma and anti-bonding orbital of sigma, means they are ending overlap and overlapping
okay.
end to end. And if they are overlapping side by side, it will be
Yes,
sidewise overlap, means bonding orbital for pi and anti-bonding orbital for pi asterisk.
for pi square. Okay.
Understood? This is
Yes,
how
sir.
this orbitals overlap. Now, now what happens? This is only the thing that you need to understand. What is constructive one? What is destructive one? What is bonding orbital and what is anti-bonding orbital? How sigma
Yes,
is
sir.
formed? How sigma asterisk is formed? And after that,
Yes.
you have to remember only one thing. Actually, for JEE advanced purpose, there is more to it, but I won't tell you now because it will become confusing to you. You just understand this one. There is, like, you fill the electronic configuration now. Kanishka, you know how to
Yes.
fill the
Yes,
electronic
sir.
configuration. In
Yes,
the
sir.
same way, in a molecule, you have to follow one order. Sigma 1s, sigma asterisk 1s, sigma 2s, sigma asterisk 2s. I'll tell you how. Sigma
It's
2pz,
just like how we fill the electronic configuration.
correct. 2px, pi 2py.
This is a bit confusing for me, but I have understand this is like the electronic configuration.
Just you have to remember these formulas that I'm giving you now.
Okay, and these will be applied in the further questions
Mhm.
we are going to solve.
Yes. The questions which
Okay.
they will ask you now, they will give you on the
Yes.
basis of these only.
Okay.
This
So
formula is
can you
for,
explain this formula like I'm confused?
I'll tell you, wait, molecules greater
Uh,
than 14 electrons. Let me write the formula.
yes, you can.
Mhm. The second formula is sigma 1s, sigma 1s less than sigma 2s, sigma asterisk 2s, pi 2px, pi 2py is less than sigma 2pz is less than pi asterisk 2px, pi asterisk 2py is less than sigma asterisk 2pz. Is for molecules less than 14 electrons. These two formulas only you have to remember. How you will remember? Just remember this order. First come 1s when you have written sigma. Okay, 1s. Similarly, after that asterisk will come. Similarly, 2s you have written, asterisk will come. Sigma again 2pz you have written, because in the p there are z, y and x also. You know,
Yes,
first
sir.
this will come. See, here only there is a catch. First this will come, then pi will come, because pi 2p x and y, they are of equal energies. Pi 2px and pi 2py, they have equal energies. Here the catch is sigma 2pz less than pi 2px and pi 2py. But when it comes for molecules greater than less than 14 electrons, this order will reverse. First will come pi 2px and pi 2py, then sigma 2pz. Okay.
Okay, sir. So, but why the order will be reversed?
It's it's just an observation, Kanishka. This is for observation and for getting the results when they were observing the molecule and they were trying to
Yeah.
find out they were trying to find out the bond order, means number of
Yeah.
lone pairs they were trying to find out. They've observed that for the order changes, the paramagnetic character or the diamagnetic character is we are getting correctly when we are changing the order of filling electrons for molecules less than 14 electrons. This is the formula
Oh,
made by scientists, actually,
okay.
chemists. It's
It's
not
like
that, hmm, this,
constant,
hmm,
and I did find it. Okay, I
just
understand.
you have to remember this formula because it's through observation. They have made one formula through observation.
Ye
Only thing you have
yes.
to remember
Uh,
is for molecules which are greater than 14 electron, the order will be first sigma comes, sigma 1s, sigma 2s, sigma 2pz.
yes.
After that, asterisk will be
Uh,
coming. But
Coming.
sigma 2pz, pi 2px, and pi 2py will come. But in
Ye
molecules less than 14 electrons, same order, but pi will come
yes,
first.
sir.
Pi 2px equal to pi 2py, then sigma 2pz.
Okay. Okay, sir.
Then the same order follows. This pi is there. So pi after pi asterisk will come, and then sigma
Yes.
asterisk will come.
Okay.
Okay, this just somehow you make a logic and try to remember this formula. And
Yes. Some.
why this is important, I'll tell you it. See, suppose we take
This
the example of
formula
oxygen.
is so long,
Hmm.
but yeah, I have to learn.
You
It will
learn
be
it,
coming up.
just what you do now. You try to just make a logic and try to write this formula 2 3 times or 4 or 5 times without looking at it. You'll remember.
I will have applied the tricks to learn this formula.
Hmm. Apply something. See, I'll tell you the example, how it is useful. Suppose we have taken oxygen. Oxygen, how many electrons are there? Oxygen atomic number is
16. Sorry, no,
8. 8.
8. It's, sorry,
Oxygen
I
is
am
8.
8.
Okay, no problem. See, oxygen is 8. So
Uh,
there are two oxygens here.
2.
O2.
So,
It's a molecule.
yes, sir.
It is 8
2,
plus 8. It will be
16.
16. Now you have to
I
fill
had just
60.
told the mass number by
Hmm.
mistake
Yes. So what you have to do is you have to fill these 16 electrons in this. Now see,
using like this formula,
this
electronic
formula.
configuration.
Yes.
Okay.
Now 16 electrons are
So,
there. These electrons are greater than 14 electrons. So we'll be using the above
yes.
formula, first one. How will fill?
So we will like this P and just like the number you have written 15 instead of we will write 16.
Hmm. So how will fill
Same
will?
as second one.
Yes, wait,
Yeah,
wait,
you
wait.
tell.
See how
Uh,
will
s-
fill sigma 1 is you'll fill 2 electrons. Sigma
two,
1 asterisk 1 is again 2 electrons. Then 2, then 2.
two.
1, 2, 3,
Everywhere
4, 5,
there will
6.
be two,
Everywhere will
like
be
in
2.
these four. And then
Every
downwards will be 16, 16, 16, and 16.
no, 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 no.
No.
Not like
Okay.
that. See, 2, 2, 2, 2. 8 electrons are filled. Again 2.
Yes.
Now here these two are of equal energy. So you'll fill like this. 1, 1,
One.
then 1, then 1.
Okay.
Totally, how many electrons are done? 1, 2, 3, 4, 5, 6, 7,
2,
8,
4, 6,
9, 10,
7,
11,
10,
12, 13,
11,
14.
12, 13, 14.
Now
Uh,
here again
we
1
have
electron,
to fill two more to complete its
16.
mass.
16 electrons.
Yes, now the 16 are completed.
16 are completed. Just you have to remember when you are filling this pi 2px and pi 2py, you have to fill 1 electrons only. First,
Okay,
1 here, then you have to fill again 1.
okay,
Earlier you were giving 2 electrons. Why we are doing this here? Because they are of equal energies.
okay.
Okay. Now
Hmm.
we find the bond order. How? The bond order formula is number of bonding electrons minus number of anti-bonding electrons divided by 2. NB is number of bonding electrons
Bonding electrons.
and Na is number of anti-bonding electrons.
Electrons.
Now, if you see here, how many number of bonding electrons are there? 2. This without
Two.
asterisk are bonding orbitals. 2 plus 2
2, yeah,
plus 2,
2,
6, 7, 8,
8,
9, 10.
9, 10, 11, 12.
No, these are asterisk. These are anti-bonding.
Oh, yeah. 2, 2, 4, 6, 8. Yeah.
So here it is 10.
10. Yeah.
What about anti-bonding electrons? 2
2,
plus 2.
2, 4, 5, 6.
Only 6 are there, na?
Yes.
It will be 6.
So
10
10 minus 6
minus
is 6 is equal to 4.
4 by 2, so
Divided
it
by
is 2.
2 is equal to 2. Okay.
What this bond order says about the number of bond this molecule has. So you remember now, oxygen is like this O double bond O. Because
Yes.
this bond order is 2, this signifies the number of bonds a molecule has. So O double, here are 2 bonds, that's why bond order is 2. Calculating this
Oh,
bond order tells us the number of bonds which are present in a molecule.
okay.
Just you have to be careful. If the number of
Why?
electrons are greater than 16 in this case, you have followed this
Yes.
order. If it was carbon, suppose CH4 or something I have done, the number of electrons will be what? 6 plus 4,
6 plus 4
10.
is equal to 10.
It is less than 14 electrons. So you will be using
Yes.
this way to fill it.
Okay. For the greater one is upper formula and for the lesser one, second formula.
Less than 14
Okay.
electrons. The rest
And
of things we will discuss in the next
and,
class.
okay, so and
Huh.
the constant terms is like 15, 15, and 25 will remain the constant. We will not change it, right?
Mhm. No, no,
Like
no.
it will be written same. Just like in the upper one you have written 2 and downward it's like 15, 15, 15. We have to not do anything with that. I'm
Mhm.
just asking that.
No, 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 no. No need to do anything with that.
Yeah, it will
You
remain constant.
mm,
Only upper one we have to solve. Okay.
only upper one. It's not 15, Kanishka. It's 1s. It's
Oh,
s.
sorry, I thought
Mm.
it's 115.
No, no, it's not
Yeah.
15. It's 1s. It's 1s, 1s, 2s,
S, 2S,
2s.
2S.
Okay.
My mistake. Sorry.
It's not
Now
15. It's
now.
1s. Okay, na?
Yes,
It's like 1s to 2s to 2p6, 3s to
2S.
3p6. You
They
used to
will remain constant.
that you have to fill, na? You used to fill
Yes.
electronic configuration like that.
Yes,
Those
yes, I remember. Those,
those
yeah.
things.
Okay.
So we'll start the
Now,
next class after this.
yes, sir.
Let's wait for some time.
Okay, sir.
You can leave.